So in this lesson, I'm going to talk about fractions, negative fractions, and how to simplify and compare a very basic fractions here. So we start with the fractions. You already know the fraction basically means division. So if you have 1 divided by 2, it can be represented as a fraction, which is 1 over 2. So this bar means division. So this is division, and this is numerator, and this 2 is the denominator. So the fraction is simply another way of representing a division. So this is 1 over 2. Now there are different kind of fractions. One is proper, improper, and mixed fractions. The proper fraction, the example of proper fraction will be, I'm going to give the examples, and then from examples we can see that why this is called proper and why this is improper and why this is mixed one. So for proper fraction, the example will be 1 divided by 4. For improper fraction, it will be 7 divided by 4. And for mixed fraction, it's going to be 1, let's say 3 divided by 4. So here, in proper fraction, as you can see, the numerator is less than denominator. So this is less than denominator, which means it's a proper fraction. Here you have numerator which is greater than denominator, which means it's improper fraction. So here you have greater than. Here the mixed fraction has a whole part and also has a fraction part. So this is called the mixed one. So it's mixed one. It's a mix of whole and the parts. So 1 3 over 4, which can also be changed into 1, can also be written as 4 over 4, which means 4 over 4 plus 3 over 4 is 7 over 4. So this is your mixed fraction. Now the fractions can be represented in different ways. So the fractions can be represented in using diagrams, or it can be represented as a number line, or it can be represented as a symbol. So the fraction as a symbol, the example will be what we were using in the previous minute. So this is the symbol 4 over 7. For number line, if I want to express 4 over 7 using number line, so it's basically a line which is 0. Let's say this start from 0, and then you have 1 here. So because it's 4 over 7, so I have to divide this into 7 parts. So 1 2 3 4 5 6. So this is 1 2 3 4 5 6 7. So 4 over 7 is going to be 1 2 3 4. So this is 4 over 7 here. Now for diagram, it's similar to the number line. We just draw a bar diagram which consists of different bars. So since it's 7, so 7 is your whole, and then we need 4 parts out of 7, which means for whole we need to divide this into 7 first. So 1 2 3 4 5 6, let's say 1 2 3 4 5 6 7. So 1 2 3 4. So this will be 4 over 7. So different ways of representing fraction using diagram, number line, or symbol. Now the next one is the negative fractions. The example of negative fraction is going to be, so the negative fraction is, let's say, negative 1 over 2, or 1 over negative 2, or negative 1 over 2. So these are all negative fraction, which basically means when you have one negative. Now that one negative can be written with numerator, that negative can be written with denominator, or that negative can be written this parallel to your bar, and we prefer this notation. So whenever you see, whenever there is a negative fraction, we will use this notation. So here, if I want to generalize it, let's say this is negative a over b, same as a over negative b, or same as negative a divided by b. And as I said, we'll be using this notation. The another thing in fraction is make sure that you do not have denominator equal to 0. So if you have a over b, this b is not equal to 0, because anything divided by 0 is unknown. It's infinity. So make sure that you don't have any 0. Whereas you can have 0 in the numerator. So 0 divided by 1 is 0. But 1 divided by 0 is infinity. So undefined. This is undefined. So next one is the simplifying fractions. So I'm going to do some examples to show you how can we simplify fractions. So here, let's say that we have 7 divided by 21. And what does simplification mean? Simplification means you have to write down this fraction in a lowest form. Now, what does that mean? I can see that 7 and 21, if I rewrite this, I can write 7 as 7 times 1, and 21 is divisible by 7, so 7 times 3. So 7 is a common factor, so you cross out the common factors. So 1 over 3 is the simplification of 7 over 21. So simplification means when you write your fraction in the lowest form. So, and to do that, what you need to do is you cancel out the common factor. Okay, so cancel out the common factor. So this is an example of simplifying fractions. So if you have another example, for example, we can do another one. Let's say 25 divided by 49, and we want to see that if we can simplify it further or not. So 25 is 5 times 5. This is 7 times 7. And you can see that we cannot, because nothing is common and nothing is going to cancel out, which means 5 over 49 is the simplest form. Is the lowest form. You cannot simplify it further. So you leave 25 over 49 as it is. Okay. Another example, if we want to do, let's say 5 divided by 25. So this is 5 times 1 and this is 5 times 5. So 5 is a common factor. So you get 1 over 5 is the lowest form here. So next one I want to do is, again, simplifying fractions. So another example I'm going to do is, let's say 3 minus 9, 2 square plus 4. So this 2 square means this is called base and this is called exponent, and 2 to the power of 2 means this exponent tells us how many times we are going to multiply the base. So now exponent is 2, which means it's telling that multiply base, which is also 2 times. So 2 times 2. So this is equal to 4. I will give you another example so that you are not confused, because here the base and exponents are same. So let's say 3 to the power of 2. So 3 to the power of 2 means this 2 tells me how many times I have to multiply the base, which is 3. So 3 times 3, and the answer will be 9 here. Just an example. Now here 3 minus 9, you know that, and so 3 minus 9 is negative 6. 2 times 2 is 4, 4 plus 4, so negative 6 divided by 8. Whenever you are simplifying, this is called an expression. So we have an expression. Expression means there is no equal to sign here. So whenever you are simplifying any expressions, you always have to use equal to sign in front of that expression. Now, we cannot leave our answer as negative 6 over 8. And why we can't leave here? Because it's not simplified. So we need to simplify it. And I know negative 6 can be written as 2 multiplied by 3. And this is equal to 2 multiplied by, I can do 2 multiplied by 2 and multiply by 2, or 2 multiplied by 4. So this get cancelled. 2 is a common factor. So negative 3 over 4 is your final answer. So whenever you get the final answer, make sure that you circle so that it is easy to understand that, you know, that's your final answer. Now the next I'm going to do is, next is 4 multiplied by 5, and then you have 7 minus 18 divided by 2. So if you remember PEMDAS, so 4 times 5, there is nothing we need to worry about the numerator. It's just a simple multiplication. So 27 minus, so here we have to use PEMDAS. So the first thing which you need to do is division. So 18 divided by 2 is 9. So 7 minus 9. And then again equal to sign in front, 20 divided by negative 2. Now we cannot leave our answer here. We need to see if we can simplify it further. So this is equal to 2 times 10, and this can be written as 2 times negative 1, and then 2 and 2 get cancelled. So this is negative 10, and that is your that's your final answer. Circle it, or put it in a box. Now the next one is, sometimes they ask you questions where they ask you to express So express 3 over 4 with denominator 32. So now which one is denominator? So we need to remember that which one is denominator here. So this one is numerator and this one is D for down and D for denominator. So this is your denominator. So 3 over 4 and we need 32. We know 4 times 8 is 32. So we multiply by 8, we get 24 over 32. That's your final answer. Now the next one is 25 over 45 and they want the numerator. So numerator of this to be 15. So what they want you to do is they want change the numerator to 15. Now I cannot change the numerator from 25 to 15, which means because why I can't do it? Because 25 is greater than 15. In the previous one, I could just do the multiplication because 4 was less than 32. So I could do that. But here 25 is greater than 15. So I cannot simply change it into 15. So the first step I need to do is I need to simplify it. So 5 times 5 and then 5 times 9. And this 5 and 5 will get cancelled. So we get 5 over 9. Now I can change the numerator to 15. Now I know 5 times 3 is equal to 15, which means I need to multiply this by 3, this by 3. So I will get, so first thing I simplified it to 5 over 9. Then the second step I did is 5 times 3, 9 times 3, which gives me 15 over 27. So that is my final answer. The next one is the comparing. So comparing fractions. I'm going to do one example here. So 4 over 5 and 7 over 9. So you need to compare and tell which one is the bigger one. So here you have 4 over 5, 7 over 9. So what we need to do here is when we are comparing the fraction, we need to equate. The denominator has to be same. So denominator equal denominator. Now for 5 and 9, so what I need to do is I need to find LCD, which is the LCD, which is your least common. LCM or LCD, same thing, division. So now here, to do that, I know this is 5 and the next number, we need to find the multiples of 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45 and so on. And here I will find the multiple of 9. So 9, 18, 27, 36 and 45. So you can see that the first one, least, means the first common factor which you see here, 45. Which means what do I need to do here is to make the denominator same. So 5 times 9 gives me 45. So multiply by 9, multiply by 9. If I am multiplying anything in the denominator, I have to make sure I multiply same thing in the numerator. Similarly, if I am dividing anything from the denominator, I have to do exactly the same thing in the numerator. Here, so this is 9 times 5 and 5. So I got 36 over 45 and 35 over 45. So which one is bigger here? This one is greater than 35 over 45. So for comparing fractions, especially when the denominators are not equal, you have to make the denominator equal. So when you have 1 over 2 and 3 over 2, this one is simple to compare, right? So we know that which one is bigger here. So 3 over 2 is the greater than 1 over 2. Whereas in this case, why it was, we couldn't do it because the denominator was unequal. So we have to make them equal. Okay, that's it for this lesson.